Okay, so let's go. We will start with this session. So, okay, let me share my screen. Let me start. Okay, just let me share my screen. Okay, can you see my screen? Is it visible? Can you see my screen?
Yes.
Okay, thank you. So let's restart. Okay. So basically, okay, let me share my course syllabus. Just a minute. So this is a research-based training program on mastering GIS and remote sensing using Google Earth Engine. So basically, we already completed the 5 classes. Today is our 6th number class. Okay. So basically, today I discuss about the 2 topic. One topic for satellite-based aridity index to for drought monitoring. Another topic for VSI or VCI or TCI for drought monitoring. Okay, as well as for yesterday or next previous session we discussed about this topic, land use land cover using machine learning, how to collect the training sample. Okay, mainly how to collect the training sample and also import the training sample in your satellite imagery. We also discuss about that. So today we also discuss about the further topic, how to make the land use land cover classification. Okay, help of machine learning with Python. Okay, so previous class I discussed about that, how to take the training sample. Okay, suppose build up water body or vegetation or land or which class you want to classify. We simply take the training sample first. Okay, this is a first method. When you work with machine learning, basically supervised machine learning, when you apply, you must need to take the training sample. So now we try to apply or train our model using different types of machine learning algorithm and check the land use land cover classification. As well as we also discuss about this topic, mainly drought monitoring, how to identify where is the extreme drought, where is the severe drought, where is the moderate drought, where is the mild drought, and where is the no drought condition. Help of vegetation health index. So basically we try to focus this paper improving the drought monitoring capability of VSI, basically vegetation health index at the global scale. So this paper we also try to focus, as well as we also discuss about the another topic. It's called that satellite based aridity index. We also discuss about that. These things basically this paper called the Modis satellite based aridity index. Okay, so this is the another index to monitor the drought condition. Okay, so both of things we try to explain. You can see this is the one kind of paper. It's called the Modis satellite based aridity index to monitor the drought condition in the specific study area. So we also try to explain about the method, as well as also discuss about the practical session, how to compute this type of things. Okay, as well as if you check this is another paper. So this paper will use at the Vegetation Health Index VSI and then identify for drought condition. Okay, so let's go try to explain about that. So basically it's work for that globally. For the globally they work in this paper, the whole world, to identify for drought condition, but we try to focus on our specific boundary. Okay, using this method. So let's go. I try to explain one by one, then you can get the idea. So you can see. Okay, let me. Okay, just right. Okay. So first of all, we discuss about this project. So it's one kind of drought monitoring, help of Vegetation Health Index (VSI). And if you check, not only for the VSI, before the VSI, we need to compute some other indices. So you can check here. Here I already computed some indices. So this is the VCI. VCI basically Vegetation Condition Index. It's called the VCI. It's one kind of index. It's called the Vegetation Condition Index. Then TCI, it's mainly called the Temperature Condition Index. And VSI, it's called the Vegetation Health Index. So after that, we simply work with drought classification. Okay, we find out this type of map. So this drought classification, I want to check only for agricultural land, only for agricultural land. So then I simply create this map. So now it's show you only for the agricultural land condition. Okay, just it show you the result only for the agricultural land, for the agricultural drought when you monitor. Okay, so then we just simply marks with the agricultural land, so then we can easily get the result. Agricultural land drought condition, where is the high drought, where is the low drought, where is the severe, where is the moderate, where is the mild, where is the no drought. Okay, and finally we also try to classification for that, so we create this type of classification. So this is the classification. Okay, and this result only for the agricultural land. But before that, if you check this result, well, VCI, it show you the all of features. Okay, not for a specific land use land cover classes, but we also try to create only for the agricultural land. Okay, then we can get this type of map. This is the agricultural land VSI, and this is the drought condition of VSI. Okay, so then we can get, you can see this type of green color indicating about that no drought. Okay, green color indicating about the no drought condition, this type of green color. Then this type of color indicating about the mild, this type of color indicating about the moderate condition, then this type of color indicating about the severe, and red is indicating about the extreme drought condition. Okay, so how I can create this type of things, then I'll try to explain, then also try to show you the practical example, then you can get the more better idea. Before that, we simply discuss about this paper. So if you check the paper, so basically in this paper they are used here the estimate the VCI and TCI. Okay, and also after that they compute make the VSI. Okay, so VCI TCI, then use these two index and compute the VSI. Okay, and you can see VSI detect the drought, use the improve the VSI study to the temporal and spatial characteristic of the global drought, it also using here. So first of all, data source. So in this time for the VCI, TCI or VSI data, they are used here this data. They take the data from 2001 to 2018. Okay, and this is the data source. If you want to also visit the data source, they are used at the National Oceanic and Atmospheric Administration for get the data. Okay, so they are computed also SPEI. Okay, Standard Precipitation Index. They're also using here. Okay, so if you check this is a drought index estimation. So for the drought index, so you can see according to this citation, VCI pixel, this is the formula about that. Okay, VCI formula. So VCI equal to NDVI minus minimum NDVI value divided by NDVI maximum value minus NDVI minimum value, then multiply 100. Okay, so you can see also this is the TCI formula. So TCI formula, basically temperature or LST, land surface temperature. So LST maximum minus LST divided by LST maximum minus LST minimum and multiply with 100. Okay, so this is the LST. So simply compute the TCI. Okay, temperature condition index. After using these two index, simply use the VHI. It's called the Vegetation Health Index. Sorry. So here you can see this is the formula about that. VSI, VSI with alpha, then 1 minus alpha TCI. So this formula when you apply, then we can easily get that VSI, okay, Vegetation Health Index. And you can see there also improvement of the VSI algorithm. Okay, there use some other regression or correlation or coefficient. Okay, they are used, and further they also calculate the Pearson correlation and also try to improve the VSI algorithm. Okay, so in this you can see they are also used. So it just simply creates some correlation. Because VCI is comprised with the two component, namely VCI and TCI. So now it's compared the Pearson correlation between VCI and TCI, and also again the PDSI, SPEI, okay, DCI, PDSI, DCI, SPI. So it's create some uh, Pearson correlation, okay, using this formula, and check the result. Which one give you the more better? Okay, so they are using the Pearson correlation. So if you check, they are used. So in this time, we're not we are simply talk about that how to create the TCI, VCI, and VSI, and how to make the drought classification. Okay, but in this paper, they are try to check the improvement of TSI index. Okay, they are improving the accuracy or others. So for that, if you check, first of all, we need the two data set. So first data set we need for NDVI and LST. Okay. So NDVI data we need for VCI, Vegetation Condition Index. We need the NDVI, and VHI. Further, we need the LST data. Okay. So VCI we can need the NDVI, and we can generate the NDVI using Landsat or Modis. Okay, we can easily use Landsat or Modis to make the NDVI. And TCI mainly temperature condition index, and we can compute the TCI using LST. Okay, we need the LST, land surface temperature we need, and we can compute the LST using Landsat data or Modis satellite data. We can compute the LST. Okay, we already discussed about that, how to make the NDVI, how to make the LST using Landsat data. Okay, we already discussed about that historical NDVI or historical LST. We already discussed about this type of things. So we need this type of data. So we can use the Landsat or Modis or Landsat. All are the same process when you work. Okay. So first of all, here I just simply take the training sample. Okay, suppose I put it's a, okay, no problem. It's a variable name. We can put any name as a variable. So we simply import our study area. So this is a study area, basically this layer. This is our shapefile boundary. So suppose this study area, I want to compute the drought condition. I want to compute the drought condition between this time period, only for the 1 year. Suppose only for the 1 year. 2015. Suppose you need the result average. Suppose 2000 to 2015 average. So then you can put the 2000 and 2015, no problem. You need the result only for the 1 year. So then put the 2015. Okay. So 2015 January to December 2015. So then it just take only for the 1 year. Suppose I need the 5 years. So you can put the 2015 to 2020. So then you can get 5 years. 2015 to 2020 January to December. So we can get the all of year, total 5 years or 6 years. 2015, 16, 17, 18, 19, and 20. Total 6 years we can get the condition. So you can easily modify from here. If you need the 6 year, 10 years, 20 years, or whatever you need, you can simply put your time, then it will be work, no problem. So I put the 2015. So I want to consider only for the 1 year condition. And you can see I put the January to December. January, December. In this case, if you need the result for a specific season, suppose you want to monitor for summer season or rainy season, so then simply put the time. Suppose your summer season or rainy season, just suppose summer season, I simply put suppose January, February, March, April, May, June. Suppose June. Okay, suppose this is my summer season. So I want to monitor the drought condition for this year in summer season. So I simply put January to and put here the number of 6, mainly June. So then we can get the result only for the January to June. Okay. So because I put the 1 is the January and 6 is the June. Or you need the result for suppose another season. So simply put the month. Suppose I need the result for rainy season. Rainy season for perspective of Bangladesh, you say that it start from July. Suppose I put the July to October. So I put here the suppose July 7 and October. I put the 10. So then it just compute the result between this season. Okay, July to October for this time. Suppose you need that total 5 years. Suppose you need the data 2000 to 2025 for summer season. Okay, summer season or rainy season. So then put the 2000 and put here the 2025. Okay, and if the rainy season, so put the rainy season month, okay, July to October. So then it computed the result in 2000 to 2025 only for the rainy season. You need the summer season, same way, just simply change the month, then it will be done. Okay, so this is the way how to we change the time period, how we can easily change the time period for the different year, different season, different month. Okay, so it also help you when you work for your own study area. So in this case, I put the time suppose 2015. 2000, I take the only for the 1 year, and I want to compute January to December, all of month I want to consider. So this is the time period. We simply choose our time period. After that, we simply start date. Start date, basically we simply define the time date object using this function ee.date.from year, month, and day. So here I put that start year. So I already defined the start year and start month. This is my start month, and this is the start date. I put the first date, no problem. After that, in date, so I simply call the end year. So end year, basically I already defined the end year. I keep the same year, so 2015 in year. Then in month, December, and date, I put the 30. So now I simply filter my data set. So I need the NDVI and LST data. When I work with the PCI or TCI, I need the two data, NDVI and LST. So for that, I simply filter my NDVI data. And if you check NDVI, so basically this one, it's the Moody's NDVI data. So this is the Moody's data Vegetation Indices 60-day global. So it's one kind of data set. It provided with the NDVI data. So this NDVI I want to use in my model. So how I can use it? So I simply import the data. It imported in here NDVI. So I simply call the NDVI and filter. I filtered this data between this time, okay, and I filter bounds with my study area, and further I simply select the band of NDVI. So now if I want to check how many images I have for the NDVI, so I simply run, we can get that how many images. If you check, we find out that total 23 images. Okay, we find out the total 23 images, and this 23 images, this is the image for 1 year. So 1 year, mainly 2015. For this year, we find out how many images for NDVI, 23 images. Okay, so we find out this is the image, 23 images for NDVI. Okay, for the NDVI we find out that, okay, for my study area 2015 for the 1 year. For the 1 year, we find out the 23 images. Okay, for my image, NDVI image. So same thing we also try to filter for LST. If you check the LST, in the LST, if you check, I already import the LST dataset. So this is the also same Moody's LST. Okay, it's a Moody's LST dataset. We also use it to compute the TCI, temperature condition index. We try to use. So just to import the data and give the name as the LST. So further, I simply call the LST. Just call the LST and filter for my time. Okay, filter for my time. And further, when I just print, it show me the result. We find out the 46 images. Okay, so if you check, we find out that 2015, this year, 1 year, we find out the how many images? 46 images of LST. Okay, we find out that 46 images. But if you check, when I work with NDVI 2015, for the 1 year, we find out the how many images? We find out the total 23 images of NDVI. Okay, so you can see, find out this type of imagery for the 1 year. I consider only for the 1 year, only for the 2015. So if you check, it show the 23 images and it show the 46 images. So if you check, this temporal resolution is not same. Okay, so this temporal resolution is not same. So if you check this temporal resolution, or you can also check it from here for the NDVI. NDVI, it's a 16-day. Okay, it's the temporal resolution is a 16-day. And if you check for the LST, what is the temporal resolution? This temporal, it's 8-day. Okay, it's 8-day. So you find out this type of imagery for the 1 year. For the 1 year, you find out that 46 images of LST and 23 images of the NDVI. Okay. So now we just need to keep the same temporal resolution. Okay. So this is the first condition. First condition, when you work with first condition, when you work with suppose VCI or PCI, use the same temporal resolution. Yes, same temporal resolution. So now this 46 images and 23 images, I just keep the same. Suppose in this case NDVI, I need to convert, it's already 23 images, and LST, I need to also convert 23 images. Okay, LST is the 46 image I find out, but I need to convert into 23 images because I need to use the same temporal resolution between NDVI and LST when I compute VCI and PCI. Okay, so now this LST 46 images, this 46 images, I need to convert into 23 images. Okay, because I want to use the because I compute the VCI and PCI. So for that I need the same temporal resolution, mainly same repeat or revisit every 16 days. Okay, so now how I can do it, it's very important. So how I can make the same temporal resolution or same revisit between LST. LST is the 46 image I have because it's 8 days interval. 46 we find out that 1 year, but NDV is the 23 image for the 1 year. So now this 46 I need to convert into 23 images. Then I find out the 23 images and it also 23 images. Then we can get the same temporal resolution. Same temporal resolution we find out. So for that, we simply use, this is a package trend start. So we simply use a package. So basically this is the full package. So it's very long code. So I need not explain in this time. So this is the package end in here. So it's one kind of package. This package helped me to convert 46 images into 23 images. I have 46 image LST. So when I use the package, when I use this package, it convert into 23 images LST for 1 year. For 1 year. Okay, there is no problem for the 1 year. So I simply use this package. I simply use this package in my LST dataset. So I simply call the LST and I call the package. So this is the package variable name. I simply call and I put the 16 because NDVI is the 16 days temporal. So I need to also put the LST also 16 day. So how I can convert? So I simply use this package. This is my package variable name or package trend variable name. I simply use and apply the 16. So now if you check, if you simply aggregate and take it, we find out that this is the 46 image of original LST, but when I use the package, it just convert 23 images. It just convert the 23 images. Yeah, because now it just create the 16 days interval. 16 days interval and create the total 23 images for 1 year. Okay. So if you have any question, you can ask me about that because it's very important. So we need to use the same temporal resolution for NDVI and LST. So for that, we simply use a package, and this package convert 46 images of LST into 23 images of LST for 1 year. Okay, I hope you also get the idea how it will work. Yeah. And this is the wrong code. So basically, it's one kind of package. So from this package, we simply call the function, only call the function. So then it will be work. Okay, then it will work, no problem. So now I can see we find out the LST 23 images for 1 year, and already have the NDVI, already have the 23. Okay, NDVI, there is no problem. NDVI is the 23, already have the 23. So now this is the main step to keep the same temporal resolution between NDVI and LST. Okay, between NDVI and LST, use the same temporal resolution. So after that, we need to apply the rescaling. Rescaling, basically, we already know about that. This type of value we need to multiply when you work with the rescaling, mainly to get the proper reflectance value of NDVI. We simply use it 0.01. So we create a function. We already discussed a lot of time this type of code, how it will be work, mainly how can easily reproject the scale value. So you already know about that. Okay, simply apply this and also rescale the LST. Okay, LST 0.02. So this is the scale value, and we simply subtract this value to get the result in degree Celsius. Okay, Kelvin to degree Celsius. So this is the one data set, mainly NDVI, rescale NDVI, and this is the rescale LST. We simply compute using a function. This type of function we already discussed about in our 7 days session, how it will be create, or everything I try to explain in our 7 days training program. So I just simply skip this type of part. Okay, so now you check, we have 23 images of NDVI. We just use and make the VCI. Okay, I have 23 images of NDVI. So now we are just use it and make the VCI. So for the VCI, if you check what is the formula of VCI, if you check this paper, they already mentioned the VCI formula. For the VCI, I need the two information, NDVI minimum value and NDVI maximum value. Okay, and then use the formula NDVI minus NDVI minimum value divided by NDVI maximum value minus NDVI minimum value, multiply with 100. So when I apply this formula, then I can easily get the result of VCI. Okay, so let's go try to compute the VCI. So if you check for the VCI, so in this case, we create a function. In this function, my argument is that I want to compute from this element minimum and maximum value. After that, I want to compute this equation. You can see NDVI minus NDVI minimum divided by NDVI maximum minus NDVI minimum and multiply 100. So then I define, you can see, so I create a function. You can see I create a function. So this is my function. In this function, I simply call my collection of NDVI. So this is the collection of NDVI. Basically, this variable collection of NDVI. Total 23 images of NDVI. Okay, simply connect the collection. Okay, so further, if you check how many images of the VCI, then we can get, if you check how many VCI, we find out that. So we find out that VCI is also 23. Okay, so now for the TCI, same way. So I have 23 images of I have total 23 images of LST. Okay, I already compute the total 23 of LST. So this LST I want to use and compute the TCI. So what is the formula of the TCI? If you check, the formula is LST maximum minus LST divided by LST maximum minus LST minimum and multiply with 100. So this formula we simply compute in our code. If you check, so we create a function. So in this function, we define the element. So further is simply call the TCI. So for the TCI, we create a function. Same function we simply create. In this function, we simply define our argument. We are just use the element and compute the minimum and maximum. Okay, and apply this formula against the LST maximum minus LST divided by maximum of LST minus minimum of LST and multiply with the 100. And further we simply use it and print how much TCI. If you check how much TCI, we find out that same 23. Okay, so now we create the collection. Okay, because image collection, suppose I need the time series chart of the VCI, I need the time series chart of the TCI, then we simply use the image collection and we can easily make the time series chart. Okay, so that's why I simply create a function and make this type of things, okay, for the TCI, and also create for the VCI for, okay, as a function. So now we simply use this type of visualization parameter. Okay, so basically if you check, it's one kind of package. Okay, this package basically help you to get the color platettes. We can get the color platettes, so we simply use it. You can see the assets, so I just use it in the plated section. So basically it help you to generate the color, different types of color. Okay, it including, so when I put the 9, so it just create the total 9 colors, or 10, 12, it created some colors. So I call the assets and color bar. I simply use it and I put the 0 to 100, and further we simply add the VCI and TCI map. So this is the VCI, this is the TCI map. So then we can get, you can see this is the VCI and this is the TCI. Okay, so this is the vegetation condition index map. So you can see this type of place it show. If you check the value also, just click. So then it show for this coordinate what is the value of the VCI. We find out, you can see the 19. Okay, TCI is the 85%, VCI is the 90%, and TCI is the 85%. Okay, and VSI is the 52.11%. Okay, for that. So if you check, we can get the VCI. So this is the vegetation condition index map. Okay, we just create, and this is the temperature condition index map we simply create. Okay, so these are two map we simply create, VCI and TCI. Okay, so these two map we simply use and compute the VSI, mainly Vegetation Health Index, we compute using the two map. Okay, so this is the VCI and TCI. We simply now, so now I want to use the VCI and TCI and compute the VSI, mainly Vegetation Health Index I want to compute. So for that, we simply join. So this VCI and TCI, we simply join. So for that, we simply use this function ee.filter equals and left field and right field, and we simply join. Okay, join by mesh key. And then if you check, we simply join, apply the VCI, TCI and filter. And further, if you print it, then we can get it. If you check, it just make the combine. It create the combine VSI. If you check it, it's combine. Oh, it's combine in here. If you check this one, if you check the features, so now it two bands, just make the combine. Okay, and make the one list, VCI and TCI. Okay, so basically we simply combine VCI and TCI, simply combine. If you think we can get just combine VCI and TCI. Okay, it's just combine two band together, and then we simply use it both, and then we simply apply. You can see the this formula for the VSI formula. Simply apply. Okay, VCI and TCI and compute the VSI. So this is the VSI. Okay, so we compile the VSI using this formula, and then we simply print how much VSI. We find out the total 23 images also. Okay, for the VSI. So further also display the VSI map. This is the layer. Simply add and get the VSI map. So this is the Vegetation Health Index map for the whole country boundary of Bangladesh. Okay, using this code, you can, any question you can ask me, please. For computing the two VCI or TCI or VSI, you can ask me. I'll try to explain again. Any question you can ask me, please. Any question?
No.
Okay, thank you, thank you. Okay, I'll also send you this type of code. Then if further you also try to practice, then face any problem, also inform me. I also guide you. No problem. Okay. So now we find out the VSI. Okay.
Thanks.
Yes, please. Okay. So this VSI, I want to apply for a specific land use land cover classes. Suppose you can see this map show the all of features, but I want to check only for the agricultural land road condition. I want to check only for agricultural land road condition. As well as I also try to make the classification. Suppose VHI, if you simply search the on Google, check some paper. Suppose VHI rents for drought. I simply search. Then it give you some rents. Okay, so you can see these rents. We find out that 0 to 24. 0 to 100%. Okay, you can say 0 indicates the extremely poor vegetation condition and 100 indicate the excellent condition. Okay, and if you check the range from here, just check some value. If you can see this type of value. So if you check some range or category, so if you can see if the value less than equal 10, then it is the extreme drought condition. Okay, suppose VSI value is less than equal 10, it means that extreme drought condition. VSI value less than 10 and less than equal 20, this range severe drought condition, then moderate, then mild, and no drought. If the value is the less than 40, okay, PSI value, then it's a no drought condition. No drought condition, it means that no drought condition. Okay, so this type of range we can also apply in our code, and further we also make the classification, this type of classification. Where is the extreme drought, where is the severe drought, moderate, mild, and no drought. So for that we simply use the classification. If you check, so in this time we simply apply the classification, this type of drought classification. So if the value less than 30, then less than 50, less than 70, less than 80, then we just simply can say if the value less than 30, we consider the extreme drought. You can also change this type of value, no problem. If the value less than 50, mainly 30 to 50, severe drought. 50 to 70, moderate drought. 70 to 80, mild drought. And less than 80, all of value we consider the no drought condition. So this is the drought condition. Is simply create a function, okay, to make the classification. And this function I simply connect with my map. Okay, so this is my VSI map. I simply connect the function variable name. So this is the function variable name. I simply connect. So now it creates the total 5 classes for the drought condition. So when I add it, then we can get this type of drought classification map. Okay, so if you want, you can also change this type of range. Okay, you can also change it. There is no problem. So basically in this time it shows the less than 30 one class, then 30 to 50 another class, 50 to 70 another class, 70 to 80 another class, and get less than 80, this is another class. This total 5 class we simply generate in here, and we find out this type of condition. Okay, you can see it show this type of growth classification map we find out. Okay, and this result only for 1 year, 2015. So you can easily change the time. I already show you that how to change the time. Okay, all of time, all of seasonal time, or a specific month, or rainy season or summer season. You also modify this type of time period and also check the result. So I take the only for the 1 year and then do this type of things. So this is my drought classification map. But this drought classification map I need only for agricultural land. Okay, I need agricultural land. I want to monitor for the drought. So now how I can
Sir,
get, yeah, please.
I want to ask, for example, if I'm doing it for 30 years or 20 years. Yeah.
Yeah.
Is there a need for me to mask the imagery?
So for that, you can also use the same. There is no problem. So for that, because you can check the NDVI is available from I think 2000. It's available. We can get the data from the 2000, and LST is also same for 2000. Okay, so between this time period, we can easily get the result. Suppose I same things. I suppose I need the result for from 2000. Suppose 2010. Okay, 2010 to
Mm.
2020. Okay, this 10 years I need the result. So now I run the and all of month, not any seasonal or any rainy season, summer, so not like that. I need the full. So then when I run the code,
Yeah,
then we
from
can easily get
January
the
to
result. Yeah,
December.
then we can easily get that
So
drought condition
the
result between
results.
this time period. Yeah.
So there is no need to mosaic, right?
No, because
Okay.
we are use the only for modis data, but when you work with the land set,
Different.
then you need to
Mm.
mosaic or create the composite. So I also give the assignment regarding this type of topic, because modis is work very well for the big study area. Okay, for the but when you work with
Ah,
the more
okay.
local area, then we need to apply the land set data. Okay, then we apply land set data. So,
Okay, so like for South Sudan, we can use Modis because South Sudan is a little
yeah,
big
then we can
area.
also use it for the big study area. We can easily use the modis. There is no problem.
Okay, thanks.
Okay. So now we can get this type of map. So it's create the map for total 10 years, 2010 to 2020. It show that this type of result we find out. Okay. Okay. So now I want to check the result only for the agricultural land. Only for the agricultural land. So how I can get the agricultural land? So first of all, we can also export the result using this code. I can see also okay, it also add the drought. It is a classification, display the classification of the drought, and it's a time series chart. Okay, we also add, you can see the time series chart also. It generate the VCI time series chart, also TCI time series chart, also VSI time series chart. Okay, so from the time series chart, we also get the idea what the scenario of VCI or TCI. So it just use this time series chart. Okay, and also export the VSI map as a GOT file format. So further we can also use it this type of map as a in our ArcMapwork uses software to produce the more better map for our disaster representation. Okay, but okay, so now how I can use the specific land use land cover data. So in this case, we are just use this land use land cover data. So it's a ES world cover data, land cover data. So this data set we can easily get the crop land or agricultural land. So if you check this the data set, ESA world cover data. Or if you want, you can also create the land use land cover map and also use it. But in this time, we are just use this ready-made data. So it's one kind of ESA world cover 10-meter resolution data set, and it give you the all of the classes: tree cover, shrubland, grassland, cropland, okay, build up, bare, sparse, and snow. And it's available from this time 2020 to 2021. Okay, but you can also
Sir,
create the yeah, please.
is there a code whereby if I have the shapefile of land cover and I wanted to convert it to a raster, is there a shapefile?
It's a raster
Uh,
file.
Code, I mean, is there a code?
So basically, it's one kind of ready-made product.
Okay.
You can see this that collection, image collection, snippet ID. So this image collection, it provide you the land use land cover for the whole world. It's available whole world, and it already
Oh,
classified this type of classes: tree cover, shrubland, grassland, cropland, build up. Okay, this type of class is classified. So now I want to use this data, and I choose only for the cropland, and this value is the 40. Okay, so just I choose the value 40, then I simply marks with my drought result or drought classification result, then I can get the result only for the cropland area. So it's not mandatory. If you want, you can also create the land use land cover for your own study area, and then further also use this land use land cover map for getting the drought for a specific classes. It also possible. In this time for the short term, we simply use it. for the ready-made product. It's globally available. So I simply call this data set. I simply import the data set and select the band. This band name is the map. I simply choose and I take the data. And you can say I simply put the equal to 40. Okay, because 40 is the cropland. Okay, 40 is the cropland classes. Suppose we set the 0, 1, 2, 3. 0 is for water, 1 is for vegetation, 2 is for build up. So same like as. So I simply put the equal to 40. 40 is the level of cropland. We simply use the level. And then we just simply marks the VSI map to include only the cropland area. Okay, only for the cropland area using this code. And then if you check, then we can easily get the this type of map. So this is the map. And if I just uncheck others, so now it simply marks only for the cropland area. If you check, so you can see this type of where there is no cropland, it just show it show the blank. Okay, there is no image or there is no pixel. So now we can get the result only for the cropland area or cropland classes. We find out the result when I just marks the VSI mean image to include only for the cropland area. So then we can easily get it. So then we can easily get this type of VSI only for the cropland area. So further, simply apply the classification. Okay, simply apply the classification. Less than 30, then 30 to 40, 40 to 50, 50 to 60, and greater than and less than 60. We create this type of 5 class, and we simply create this type of classification map. Okay, for the cropland drought classification map. So I create, you can see this type of map. It generate. Okay, this type of place, no drought. Okay, so there can be the extreme drought, severe drought, or moderate drought. You can easily identify. Okay, only for the agricultural land for the whole country boundary of Bangladesh, you find out. And further also export. And this is the legend code. Simply add the legend, this type of legend. So now you also try to do this type of homework. I also give the homework. So you try to compute the VCI, TCI, and VSI using the Landsat data for the small study area. Okay, just use the same concept. Okay, and then use the same formula, and further just compute the VCI, TCI, or VSI using the Landsat satellite data. Okay. And so you also try to create, okay, using the same way. Suppose using the Landsat, we can easily compute the NDVI. Okay, we can easily compute the using the Landsat. We can easily compute the NDVI. We can easily compute the NDVI. Then we can compute using the Landsat. We can also compute the LST. Okay, we can also compute the LST. So NDVI, simply use it for VCI. Okay, and LST, simply use it for TCI. Okay, and further use the VCI and TCI, compute the VSI. So also try for the small study area. It's very helpful because it's a 30-meter resolution. Okay, when you work, we can get the better result. But MODIS, it also work for the big study area. We can easily work with that. We can get the very better or global. Yeah, so it's look more pretty when you work with the big study area. Okay. And then we simply compute the drought condition. Okay, any question?
No, thanks.
Okay, thank you. Okay. So I'll just send you the code. You also try to practice again. Then I hope it will be more better for next time. So now we talk about this topic. Okay, this thing we already discussed about that. So just I simply run and show you that again. So this type of important library we simply import, simply install first time. Okay, so let me change my email because I want to use it. Okay. Simply install this type of Python packages. It's done. So further is simply import all of library. Also, okay, also click on here and connect to your Google Drive. It already connected. Okay, just okay, so now run it. I already explained this type of code, how it will be worked. Okay, so just simply run. Okay, how to read the all of information of the images. Then this is the image information. And we also try to check the shape, image shape. Then we simply use the transpose function to change the. Okay, so then red, green, blue. Simply create the RGB. We can get this type of satellite imagery. So this is my satellite imagery, and further we also have the training sample for this type of specific training samples. And okay, we find out this type of training samples mainly it extract the spectral signature value with the level. Okay, mainly 0, 1, 2, 3, it's a level. And also have this type of spectral signature b1, b2, b3, b4, b5, b6, b7, b8, all of spectral signature value. Okay, so this is the training sample, and training sample and satellite image must keep the same CRS. Okay, it's very important. Sample, you can see this is the CRS, coordinate reference system, and image must keep the same CRS. Okay, sample and also image have the must same CRS. So further, we simply display this imagery. So now it display the imagery and sample at the same time. Okay, so it's okay. It show. Oh, I think so. Yeah, I think it show the big screen, so that's why it show this type of problem. It's not a problem. Okay, so you can see it. Okay. After that, we simply just use the samples. Then you can get all of geometry, mainly all of points, latitude, longitude value. That is the geometry. So now in this geometry, so you can see this is the very this is the code. We create some sample, mainly x and y. We create the sample, coordinate sample. We simply use it array samples for point in sample geometry. we simply extract the all of latitude longitude value. Okay, and also and can connect with the band values. Okay, so after that we simply call the numpy library. Okay, so this is the code. So basically it extract the point latitude longitude value and also get the band values. Okay, and store the array samples call a variable. So now we simply use the x and y. Okay, all of training sample and level. And then run and check the x. We find out, you can see this type of shape. So 140 training sample, 140 training sample, and total 12 bands. 12 bands. So now we simply apply some model. So first of all, we simply call the scalar model selection. Scalar model selection. We need to import the train at test field. Okay. Then scalar matrix. Import the classification report to check the accuracy. Scalar matrix. We can also apply the kappa accuracy. Okay, coefficient accuracy. Then confusion matrix and scalar pre-processing from the level encoder. So we simply import this type of library for the different purpose. And this is by x. Okay, x basically it's the training sample with the bands, total bands. And further sample c1 basically it's our class, this column is straight to the class level or class name, water, then vegetation band, all of those. Okay, and if I just simply get only for the values and also level encoder and then check the value only, so then we can get, you can see 0 is the one class. Okay, 1 is the another class. Okay, it is a level 2, then 3, total 4 class. Okay, 4 class. So now we simply apply the machine learning model. So we put the x train, x test, y train, y test, and apply the train test speed, this function. Okay, train test, I already import, you can see train test and speed. So this is my library. I simply call train test speed and speed the, you can say xy. I put the test site 0.3, so it take the 70% data for train and 30% data for test. Okay, when I put the 0.3, it means that it take the 30% data for test and 70% data for train, and then I run it. So now it spilled the data, and I simply call the XGBoost classifier or gradient boost classifier. So I already imported it. So just I call my classification and simply fit the model or train the model. Okay, so now okay, it also fit. It's a gradient boost classifier, and further also check the accuracy. So you find out, you can see this is the train accuracy and also test accuracy. And now we simply use the model. This is my model variable name, and predict the x test. So simply run it, and now we simply check the prediction report, classification report. Just run it. We find out, you can see this type of things: precision, recall, f1 scan support, and get the accuracy, micro average, weighted average. We find out that. So accuracy, we find out the 98% accuracy in here. Okay, and also f score for all for every single class, 0 1 2 3. It's a class. Suppose 0 is for water, 1 is for vegetation, build up others. Okay, so the all of information classification report. And if you check the matrix, okay, so then it create the matrix also. So if I just run the code, it show the matrix, this type of matrix. If you check, we find out that, so it's called the matrix. Okay, it shows the matrix. You can see basically confusion matrix table. Okay, so it's called the confusion matrix table. And I hope you already know about the confusion matrix table, because we already discussed in our Google Earth Engine 7 days class for the confusion matrix table. Suppose barrel land, it means that this 12 it correctly classified and no other mix with others. Then build up 12 correctly classified and no other mix with others. Vegetation 6 correctly classified and 1 is wrongly classified pixel. And finally you can see water body 11 is the correctly classified and no other mix with the water body. It means that, so it's one kind of confusion matrix table. So further is simply predict our image. So we simply use it and predict our image, and predict image shape if you check. So this is the predict image shape. We find out that. Then predict image we try to display, and we simply call our model and predict the prediction image. Just to run it. So now it create the predict image or land use land cover image. So I simply reshape and plot. Okay, so finally find out, you can see this type of classification map. So this type of blue color is a water body, yellow is that barren land, red is for build up, and this type of green is for vegetation. So this is our final out prediction result. We find out that. Okay, so it also help you to compute the area. So let me show you the check the run, show you the result. It compute. Okay, let me run and show you that the result mainly chart. Okay. It show a problem. Just a minute. Module num5 has no attribute the float. Okay. Num model num5 has no attribute the float. Float. Okay, just let me remove it. And now I can. Okay. So now further check the result. You can see it create this type of area. So zero number class, how much area? Parent how much area? Build up, how much area? Vegetation, how much area? Water body, how much? I find out that. And finally, we just simply make a plot. Okay, create this type of plot. Water body, how much area? Vegetation, how much? We find out this type of plot look like that. And also compute the percentage. Suppose how much percentage of each classes. So it also compute the percentage. So let me show you that. And show the plot. I got a problem. It show that problem. Explode the multi-billion x not 5. Okay, just let me check it. Okay, I'm going to try to check. Okay, it's done here. So it create, you can see this type of pie chart. So you can create this type of pie chart. Okay, suppose how much build up, how much percentage, 64.54%, then how much vegetation, 0.75, water body, and also bare land. Okay, so this is the way how to apply the Python. So in this case, if you check, we are just use only for the one model. Okay, so we are just use the gradient boosting classifier. Okay, gradient boosting classifier, but we can apply it for the any classifier. Okay, suppose you can easily apply the random forest or any others. So we need to change in here, also only change in here. Okay, then we can easily apply the any types of machine learning model. Basically this it's create the model, so this variable is to our model, so you can easily change it for the different model and apply for our different types of model. So inshallah further class we'll also discuss about the other model. Okay, for the random forest or others, how to apply. Okay, and get the same result. Okay, get the same, then we have to check the accuracy and also compare the result. So this is the gradient boosting model. So if you check the more details about that gradient boosting model or gradient boosting classifier, so you can see in this model, I also share with you the link. Then you can get all of parameters. You also try to read this type of parameter. Okay, then you can get the more better idea how it will be work. This type of model. Okay, so all of those it's including in here. So you can see this model. Basically, it just come from the gradient boosting classifier. Okay, gradient boosting classifier. Gradient boosting classifier. So if you check the random forest classifier, so this is the random forest classifier. Okay, so you can see the random forest classifier. You can see this is the scale and assemble, import the random forest classifier. So this is another random forest classification. We also use this type of model. So further initially we discuss about this type of model. So in the meantime, I also send you the code link. Okay, and you also try to adapt this code for your own study area. Okay, suppose you can simply choose a study area, and further you can also download the imagery and also make the training sample, and further just apply the same code and make the classification. Okay, then we also further also discuss about that how to apply different types of model. Okay, same code we just use, but we apply the different types of model and get the result from here. Okay, any question please? Any question?